Hi, welcome to video number 2. Alright, so we left off at number 14. Find all rational roots of the function. So the rational root theorem says that if we take the factors of the constant, which would be 1 and 5, these are numbers that divide evenly into the constant, and divide them by the factors of the leading coefficient. So what numbers divide evenly into 2? 1 and 2. So if I look at combinations of this numerator with this denominator, I have positive and negative 1 and 5, dividing it by 1. Positive and negative half and 5 halves. I'm hoping that either 1 or 5 works, so I don't have to use the fraction. So again, when we do our division here, make sure that you're putting a placeholder in for the squared term because it is not there. So let's start by using 1. Hopefully it'll work. 2 times 1 is 2, and I add. 2 times 1 is 2, and I add. I got lucky. Okay, it worked. And by worked, I mean remainder of 0. So now I have 2x squared plus 2x plus 5, and I'm going to factor that. So I have 2x and x. Oh, 5 and 1? No, that wouldn't work, because that will give me 7. 1 and 5. No, that would give me 7. That'll give me 11. Let me try the quadratic formula. Where'd my pen go? Hello? Oh, my board died. Great. Gotta plug it in. Okay, we have power. All right, I've got to do the quadratic formula here. Oh my gosh. All right, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, here's why I couldn't factor it. Look at my discriminant. It is negative. Underneath the radical is a negative number, which means that 1 is actually the only rational root. So this is a cubic that crosses at 1, so it probably looks like that, and it just doesn't do this. It doesn't come back down and come back up. It's only crossing 1 time. It might do this too, something like that. That's okay. 1's going to be the only thing that works here. All right, same thing over here again. Find the rational roots here. So I'm testing out 1 and 3 divided by 1 and 2. So let's try 1. 2, negative 3, negative 8, negative 3. 2 times 1 is 2, add. Negative 1 times 1 is negative 1, add. Negative 1 times, nope, not going to get 0. Let's try 3. 2 times 3 is 6, add. 3 times 3 is 9, add. 1 times 3 is 3. Awesome, it worked. Let me see if I can factor this. 2x squared plus 3x plus 1. 2x plus 1x plus 1? Let's see. 2x times x is 2x squared. Outside's 2x, inside's 1x. That's 3x. 1 times 1 is 1. Perfect. So solving this, I get negative half and negative 1. And x equals 3. There's my 3 roots. Last page, but there's a lot on it. Okay, find the domain. Domain is when my denominator is equal to 0. So I'm going to factor out by GCF here. If I take out a negative 4x, I'm left with x plus 1. No, x minus 1. Setting both of those equal to 0 is going to give me 0 and 1. So my domain is x cannot equal 0 and x cannot equal 1. Same with 17. I'm going to factor that denominator. So I see a GCF of 2, so I'm going to pull that out. And I have x minus 3, x plus 1 is how it factors. So my domain is x cannot equal 3 and x cannot equal negative 1. So I'm taking the denominator, setting it equal to 0, and factoring. Taking the opposite of these numbers because I'm saying x minus 3 equals 0, add 3 to both sides to get x by itself. Find all asymptotes. So vertical asymptotes are found the same exact way as domain. These are the vertical asymptotes. These are why we are not defined there. So if I take 4x plus 16 and set it equal to 0, I get negative 4. This would be my vertical. Since my numerator is bigger than my denominator in power, I have to do some long division to find my slant asymptote. 4x goes into x squared a fourth x times. A fourth x times 4 is x squared. A fourth x times 16 is 4x, and I'll subtract. I get negative 2x minus 3. How many times does 4x go into negative 2x? Negative half times. So negative half times 4 is negative 2x minus 8. It really doesn't matter what the remainder is. This is the line, my slant asymptote. So I have a y-intercept of negative half and a slope of a fourth. So up 1 over 4. And that's going to be my slant asymptote. So my graph would be somehow nestled in between these asymptotes. 19, I'm going to factor out my negative first. Didn't really need to make it that bold. X squared minus 2x minus 3. So that gives me x minus 3, x plus 1. So my vertical asymptotes are at x equals 3 and x equals negative 1. Since my denominator is bigger than my numerator, my horizontal asymptote is just at 0. Switch colors for that. So I probably have 3 pieces to my graph here. Okay, find the hole. Holes come from when the numerator and the denominator factor and something cancels out in both the numerator and the denominator. So my numerator is going to factor into x minus 3, x minus 3, x minus 1. My denominator, I'm first going to factor out the negative. So that leaves me with x squared plus 3x minus 4. And that's going to factor into x minus 1, x plus 4. So here is my repeated factor, x minus 1, x minus 1. So that means my hole is at positive 1. To find out the y value of the hole, I plug back into the stuff I didn't cancel. Remember, there's a negative there in the denominator. That's important. So I have 1 minus 3, that's negative 2. And then I have 1 plus 4, that's 5. But there's a negative here. So that means actually 2 negatives make a positive. So I have positive 2/5. Over here in this one, you can factor out an x. That leaves you with x squared plus x minus 12, which factors into x plus 4, x minus 3. Denominator, we just have a GCF of negative 4x, which is going to leave you with x minus 2. This x and x is my factor that cancels. So that means that my hole's at 0. I plug a 0 back in. 0 plus 4, 0 minus 3. 4 times negative 3 is negative 12. Then I have negative 4 times negative 2, which is 8. And that is going to simplify to negative 3 over 2. Okay, completely graph all this stuff. So we're doing all of the above. Vertical asymptotes, horizontal asymptotes, holes, x-intercepts, and then y-intercept that we didn't do yet. So let's start with factoring. So I'm going to factor the numerator, x minus 3x plus 2, and I'm going to pull a 2 out of the denominator before I factor it. So 2x squared plus 3x plus 2. So that is x plus 2, x plus 1. Okay, I found a hole, so I'll do that part first. Hole, hole. My hole is at negative 2. Plug a negative 2 back in. I get a negative 5 in the numerator, and then a negative 2 plus 1 is negative 1 times 2 is negative 2. So again, positives here. There's my hole. Plugging the negative 2 back into the stuff I did not cancel. So this only leaves a vertical asymptote at one spot, which is my negative 1. That leaves me with an x-intercept in the numerator, which is at 3. And then I plug in a 0 to find the y-intercept. So 0, 0, I'd be left with negative 6. 0, 0, I'd be left with 4. So my y-intercept is going to be 0, negative 3 over 2. For the horizontal asymptote, I'm looking at the powers. The highest power are both 2's. Those match. So I take the ratio of the leading coefficient, which is a half. So y equals half is going to be my horizontal. I should probably draw a straight line. Okay, so here is my graph. Y-intercept at 0, negative 3 halves. So that's there. X-intercept at 3, 0. That's there. Vertical asymptote at negative 1. That's there. Horizontal asymptote at half. What else didn't I do? Oh, hole at negative 2, 2.5. There. That's it. Connect. Connect. Okay, last one. I'm going to factor numerator, factor denominator, see if I've got any holes. X minus 3x plus 3. Factor out a negative 3, and I'm left with x minus 2. Okay, no holes. I do have then a vertical asymptote at 2. I have intercepts at 3 and negative 3. To find my y-intercept, I plug in 0. So that's 0, that's 0. So my y-intercept is at 0, negative 3 over 2. So that's here. No holes, we said. All right, slanty time. So the horizontal asymptote comes from the numerator being bigger than the denominator. So I'm going to, again, do the long division, putting a 0 in for a placeholder. How many times does negative 3x go into x squared? That would be negative 1/3 x times. Subtract. How many times does negative 3x go into negative 2x? Ooh, that's a tough one. Let's do negative 2/3 times. So 2/3 times 3 is just 2. So that leaves me with 2x minus 4. Subtract, and I get negative 5. So this is the equation of my slant. For the equation of the slant, this is the y-intercept. So negative 2/3 is about there. And then my slope is down 1 to the right 3. So down 1 to the right 3 is about there. And then up 1 to the right 3 is about there. So there is my slant. And then my graph just has to love on those asymptotes.